Exacto.
We're fine, we are fine. ¿Qué tal? Buenas tardes. Mi nombre es José Ángel Gutiérrez Pabello. Bienvenidas a todas, todos y todes a este auditorio en donde, bueno, quisiera comentarles antes de hacer la presentación de el investigador que viene a hacer el seminario, que el día de hoy tuvimos la fortuna de firmar unas bases de colaboración con el Instituto de Energías Renovables de nuestra universidad en términos de un proyecto que se está realizando en conjunto con la Facultad de Medicina Veterinaria y Zootecnia en relación al tema del seminario que pueden ustedes ver en el título en la pantalla, Agrovoltaicos. Y comentarles, para los que no lo sepan, que en uno de nuestros centros, el que está en Topilejo, el Centro de Enseñanza Práctica, Investigación en Producción y Salud Animal, es el recipiente precisamente del proyecto y en donde va a iniciar este peregrinar, yo diría, en donde nuestra facultad se tiene que mover hacia una producción diferente a la que hemos venido planteando, con ecotecnias, con una gran cantidad de proyectos que nos lleven a una producción sostenible. Quisiera yo comentar que dentro de el liderazgo que hay en este proyecto está el doctor Aarón Sánchez, que es investigador del Instituto de Energías Renovables, que está presente aquí con nosotros. También quisiera yo comentar de parte de nuestra facultad, es el doctor César Augusto, quien está, Lizarazo Chaparro, quien está como líder de este proyecto. Él es el director del CEPIPSA, así es conocido nuestro centro, y también no quiero dejar de mencionar que tenemos un tercer colaborador, que es la Universidad de Arizona, de donde viene Greg, que es nuestro invitado especial el día de hoy, y de donde también quisiera yo presentar a el doctor José Lever, y José Lever, excelente amigo y vinculador, quien él es el vicepresidente asociado para Asuntos México-Estados Unidos, contratado por la Universidad de Arizona, y él tiene su oficina aquí en el campus, entonces siempre nos ayuda con este tipo de proyectos, este y otros más que están caminando. Pasando al seminario, pues quisiera yo comentarles, el título está en la pantalla, recordarles que va a ser en inglés, no hay traducción. Greg va a tratar de hablar despacio. You are gonna talk slowly so people can understand. Y sus preguntas las manejaremos al final. Esperemos que responda a la expectativa que tienen ustedes al venir a este seminario. Y nuevamente decir que la mayor parte del contenido que ustedes van a ver está orientado hacia plantas, pero el doctor Greg nos va a dar algunos ejemplos de cómo lo podemos asociar a la producción animal. Entonces, sin más, quisiera yo presentar... Sí. Las preguntas, pues aquí las manejaremos. Sin más, pues quiero presentar al doctor Greg Barron Gatford. Él es profesor asociado de la escuela, como dice ahí, de Geografía, Desarrollo y Medio Ambiente de la Universidad de Arizona, y quien es el experto en agrovoltaicos. De hecho, me da gusto ver aquí también a una estudiante de Iztacala que tuvo la oportunidad de hacer una estancia en la Universidad de Arizona y que ahora es la experta, vamos a decir, de los estudiantes en este tema, y que gracias por estarnos acompañando. Y así como esto, existen oportunidades para nuestros estudiantes para que puedan asociarse a este proyecto y ver las ganancias que podríamos tener en el futuro. Entonces, sin más, Greg, please come and speak to us.
Thank you, everybody. I'm going to take your picture so I can show my lab group. Perfecto. Well, thank you for the invitation. Thank you for such a beautiful welcome to Mexico City and other parts south of Mexico. And lo siento para el English, but I have an amigo and hermano and Jose Lever who will translate if there's some confusion. It's okay? Clase? Sí? Okay. Soy un profesor, so I like to say yes, yeah, and see yes, okay. So today I am talking about this project, a project that we think brings lots of opportunities for creating a more resilient, a more sustainable future in terms of food and energy and water. And I recognize that today many of us are coming together and we are slightly outside of our comfort zone. When our energy and we're connecting with people from veterinary schools, we're stretching ourselves to become better scientists for better solutions. And today I'm stretching you a little bit more because this is mostly about plants that will feed the animals. So again, stretching you a little bit more. The connection here is that we are growing crops in the full sun and crops underneath the solar in this concept we call agrovoltaics. And without good crops, good forage, good alfalfa, good hay, you cannot have good animal health. And so there is a direct connection, even though we have not yet studied actual animals under the solar. This is definitely the next step, the próximo step. Okay, so I am Greg Barron Gafford in azul. Todas las personas en oronja are estudiantes undergraduates. So here are some of them. And I mention all of these undergraduate students because they are a very important part of our team, and to stress that I hope that some of you will come to the university and some of you will be involved in the project here. The people in red are some of our staff members, and it takes a team, an interdisciplinary team, to do this kind of work because it is agriculture, it is energy production and engineering, and it is about understanding water resources, and it's also the social sciences. So we can start to understand what are some of the barriers, some of the challenges, and some of the opportunities when we think about a new way to do agriculture or a new way to do renewable energy. So I will start with some of the challenges. All of us, for the most part, we want sustainable agriculture. But food production is vulnerable to a changing climate. Whether you're talking about a very extreme environment like southern Israel, which is one of our collaborators, or the way we do agriculture in Arizona, where we use lots of water. It's called flood irrigation instead of drip irrigation. It's not very sustainable, but it's how the practice has been done for the last 50 to 100 years. So a change is necessary. And the climate is changing, and it's threatening our ability to have sustainable food production. The dark colors represent more money for food production in these different counties. So you can see Tucson is about here. This is Arizona and California. And there's lots of food production. A big part of our economy is from agriculture. But the projections for a changing climate are more stress. Dark brown colors, cafe, indicate stressful climates, water stress. So if you have lots of production and you start to add more stress, you're going to have a map like this. Cuando rojo indicates decrease in agriculture production, right? So it's a real problem because we have a growing population, but a shrinking capacity to feed them. And we're not just talking about, on this graph, increases in temperature, and this is how much we will reduce our ability to produce food as the climate becomes too warm. But look at the bottom graph. Mortality is of the workers, not just the crops. We are expecting, under a changing climate, the condition is too hot and too stressful for even the laborers, the people who do the food work. And so again, we need to find a solution for how we produce our food. This pressure, this challenge of food production is already starting to create a change on the landscape. So in this image from Google Earth, mira, Solomon, all of these are fields for agriculture. And this is in 2012, 2012. And look in only 5 years, solamente 5 years, how this image will change because there's less water, so less food production. You can see all of these places that used to be farms are now solar fields. So I'll go backwards again so you can see the change. 2012 to 2017. So this means we're having, if you change from food production to renewable energy production, it's very difficult to go back. And so, again, if we have more people, we need to keep some land for food production, whether it's crops for people to eat or grazing grasses, alfalfa and hay for the sheep to eat. Okay, so this is one challenge. That's the food. For the other population, we have a challenge about renewable energy. We want more renewable energy so that we can have more energy independence, so that we can work towards a better climate. But even renewable energy is sensitive to climate change. So in this map of the United States, you can see all of these dark colors. These, oh, and in Mexico, all of these dark colors represent areas where you have a lot of potential for renewable energy production. It also looks like a weather map, yeah, where the places where you can produce the most renewable energy for photovoltaics is also the hottest place. Similar situation in Mexico. We have similar rates of maximum energy production from renewable energy. But I mentioned that this is sensitive to a changing climate because this graph shows the efficiency of a solar panel as you get into higher temperatures. I didn't know, because I'm an ecologist, that solar panels don't like really hot temperatures. Did you know this? I did not know this. So, your Mexican clicker is tricking me. So the efficiency of solar goes down with temperature. That means under a warming climate, we might have more challenges with photovoltaics being a good renewable energy source. So taken together, we can start to think in terms of the United Nations, where we have sustainable development goals. Some of them, number 7, is around renewable energy, where we want to increase our percentage of renewable energy on the planet. And we actually need to double the efficiency of that renewable energy. We need it more and more efficient. But we also need our land for food production so that there's universal access for food. We need to increase the productivity of that food per hectare because we have a growing population, all while trying to maintain smart use of water, because water resources are also a challenge. So how do we reach all of these goals at the same time? Well, one possible solution is to think about co-locating, bringing together vegetation and renewable energy so we can have food and energy and water benefits. And to the left, a la izquierda, for panel A, we're talking about grasses for animals to eat. A la derecha, with B, we're talking about food crops more for the humans. In both examples, you can utilize the shade from the solar to help our plants survive during periods of drought and temperature stress. Because think about when you're really hot, you go stand in the shade if you have this opportunity. But plants don't get to move. Unlike the animals, they're stuck. So we are bringing the shade to the plants. So that's the food. In terms of energy, we're talking about improving energy production. That's where I'm using these arrows. These arrows pointing up represent the water loss from plants. Do you remember the word for water loss from plants? Clase? Remember? Yeah, transpiración from the plants. And the transpiración creates a cooler climate. And so we can use that transpiración to actually cool the solar panels. So in that case, if we can cool the solar panels, we can make it more efficient. So again, another win in terms of food, win in terms of energy. And ultima, a win in terms of irrigation. So think if I had my water and I poured some in the sun and I poured some in the shade. Where would it stay wet longer? In the shade. Thank you, class. In the shade. So that means every time we have to irrigate, the water will stay in the soil longer to do the work of keeping the plant alive, in that case, helping create more forage for the animals. So that means we could use less irrigation for our food production. And so now we're talking about not just having energy production come from our system, and not just food production come from our system, but some version, some type of a co-location where you can still have food, you can still have energy, you can actually work to conserve water, and you see this is wider. You can create more revenue because you're actually utilizing the top and the bottom of that system. Because I knew I was talking to many people who are in vet sciences, just a quick refresher on photosynthesis, our plant physiology. So these are our two examples: normal crops growing in the full sun and crops growing under the shade of solar panels and indirect shade from solar panels. And in the morning, when you're having our breakfast, that is a good time for plants. It's much cooler, the temperatures are lower, there's more humidity, and so the plants do really well. So let's think about the plant. We all know plants, they do photosynthesis, right? Remember this? Even in biology for plants class. Carbon dioxide goes into the plants. Just like us, they have little pores. The pores, you remember the word? Stomata, the stoma. Stomata lets the carbon dioxide into the leaf. But every time the plant opens its pores to let carbon dioxide in, water escapes. This is a constant challenge for the plant. The plant doesn't want to lose water, but it does lose water every time it does photosynthesis. And in the morning, you can have good conditions for photosynthesis. You actually have good conditions for transpiration. And again, in this case of transpiration, we're using it to cool down the solar panel. But the question I always get is, even if I went to a veterinary school, I remember from my biology class about plants, plants need sunlight. Yeah? So how much sunlight does a plant need? On this graph, we are looking at a plot of photosynthesis on the y-axis and light level on the x-axis. And so you can see, yes, your professor was true. You learned that correctly. Plants do need more sunlight to do more photosynthesis, but at some point, they saturate, a point of saturation, where no more sunlight gives you more photosynthesis. Too much sunlight can actually reduce your photosynthesis. Think about me gusta mole. Mole es bueno lunes, miércoles, pero sábado and domingo, come on, that's enough mole. For the plants, it is the same way. So the photosynthesis rate increases with light up into that certain point. And this is the point of where we are outside. You can see in the natural world, we are way beyond the saturation point. So the trick is to use our collaborators that know about the renewable energy to say, design the system to let through, to allow the most appropriate amount of light for the vegetation. And so you can see, you can take away 2/3, or you can take out 60% of the sunlight, but you're not taking out 60% of the photosynthesis. This is what we're trying to utilize. More importantly, as it becomes more stressful, you might say, well, what about what's the shape of this curve when it's really hot or when it's really dry? Actually, most of the reduction of photosynthesis comes out here at this highest level. Your saturation point doesn't change as much. That'll be important as we get to later. So as we keep thinking about this, we talked about transpiration. There's also evaporation. Together, that is evapotranspiration. So in the morning, you have lots of water because you used irrigation in both situations. But see, the arrow for evaporation is very large. But as we talked about with the water example, the evaporation in the shade is less. So throughout the day, when it's time for almuerzo, the soil moisture is depleted more quickly in the sunlight environment than it is in the shady environment. See, less water still in the soil. What that means is if there's less water in the soil, the plant becomes stressed in terms of having water to drink through its roots. And so you will start to have a reduction in that transpiration. Plants are smart, just like the animals you study here. Plants are smart. They can sense they're running out of water, and so they close their stomates. They close their pores so they don't lose water. So if the stomata are cerrado, that means no more carbon dioxide to go in. So you have less photosynthesis. This is the connection between a stressful climate and the reduction in photosynthesis. So again, in the full sun in the middle of the day, it's much sunnier than it is in the shade. Again, a very simple principle that we are applying to this system to make it work. And again, in the full sun situation, the evapotranspiration just goes out into the atmosphere. And Aaron was telling me sometimes it can be very windy, and this transpiration just blows to the Estados Unidos. I don't know. But in agrivoltaics, the transpiration stays within the system and keeps the atmosphere more wet, more humidity, which is better for the plants. So again, now this is the type of data that we collect at the installation that I showed you from Biosphere, where now we are looking at during a single day. The dark represents when there's no sun, sun time, no sun at ocho in the noche. And you can see that during the day, air temperature is cooler in agrivoltaics, which is shown in blue. And also this measure called vapor pressure deficit. It is a fancy word for how dry is your air. And you can see the air is more dry in, there we go. The air is more dry in the full sun setting, so it's more humid in the agrivoltaics. Again, these are two parameters that are important for the plants to grow. So I just talked about temperature. Earlier, I talked about light. So this is a graph of temperature versus photosynthesis. And you can see plants are like us. They don't love it very cold. Okay. Plants don't love it very cold. They don't love it very hot, somewhere in between. On this graph, this is the full sun, and this is the shade of the agrivoltaics. So we're closer to the optimal performance of that grass, which again, if you're thinking about sheep or vacas, it's to keep the grass most healthy, to grow fastest, to support the plants. So the challenge here is that we can have a small reduction in photosynthesis because we're in a shadier environment, but maybe more photosynthesis because you're at a better temperature. But what is the response of the plant? This is why we have to do the research. The research I'll show you today is from Arizona. We are a drier place. And Monse, on the tercera row, the third row here, came and helped us do some of these measurements. What is the response of the plants in Cuernavaca? What are the response of the plants in Mexico City? This is the research we need to do. So here's an example of one of our students working on the crops in the full sun and in the shade. Again, it is very hot in the summer. And so I don't know if you have rock, paper, scissors. You know this game for children? This is how we do it to see who has to do the measurements in the sun. Or if you're the youngest, you have to do the measurements in the sun. But we have an instrument that we can collect. We put this chamber over the leaf, and it's very similar when you go to the doctor. They check your pulse, they check your blood pressure. It's not a picture of your entire health, but it's how you're doing in that moment. And so this is our measure of how these plants are doing in this moment. And why are we measuring photosynthesis? Again, photosynthesis is the process of carbon uptake by the plants, and that carbon is their fuel to grow, to reproduce, to make fruits. And so we wanted to know how well these plants were doing throughout the entire day. And so we started before the sun came up. Another estudiante, his name is Kai. And for every hour, we match the conditions in the chamber to match the conditions in the full sun, or the conditions in agrivoltaics. And then we repeat these measures every hour from before the sun comes up, during the hot part of the day, and at the end of the day. Every hour we take these measurements. And I will show you, I'll explain what these graphs are. So this is a plot of photosynthesis during the day from 4 o'clock in the morning until 8 o'clock at night. We measured 3 crops this past summer. Basil, you know basil? Yeah. ¿Cómo se dice basil? Abaca, gracias. Beans, frijoles rojo, y tomate. Tomate. Ah, easy. Okay. And you can see during the nice times of the day, in the morning when the conditions are very good, that the plants in the full sun, shown in red, they do more photosynthesis than the plants in the shade because it's a good time to be in the full sun, and so you get more photosynthesis. Pero during the stressful part of the day, the plants in the agrovoltaics in blue are doing better than the plants that are in the full sun. And so the trade-off is, what time of day are you doing better? And also, these patterns vary by plant. You can see a basil plant, the sun comes up, it does lots of photosynthesis, but by 11 in the morning, the plant is done. So the plant is green todo el día, but is not doing photosynthesis todo el día. So to know how well they are doing, we have to take these hourly measurements and then we add them all together. And this graph tells you how much carbon dioxide did that plant get during one day, during the good times and during the bad times. Again, because this is the resource to grow and reproduce. And so the main points here is the impacts of agrivoltaics were that you can, back. For basil, it doesn't matter. You can be in the shade or you can be in the full sun. You get the same level of carbon dioxide uptake. So basil, it doesn't matter. Shade or sun is bueno. For the frijoles, growing in the shade actually meant a 30% increase in their production. So even though in the morning you did better in the sun, most of your day you benefited from being in the shade. And the mismo for tomate. You can see we also performed all of this experiment under 100% irrigation. What that means is the farmers already know how much water is required to grow these crops in the full sun. But what about in the shade? Remember, there is less evaporation, so having 100% water in the shade is actually too much water. The plants did not need it. And so for that reason, we reduced our irrigation. Well, maybe I'm using the batteries too much. We cut the irrigation by 50%. And you can see, look at this, 12 for the beans. So cutting back the irrigation by 50%, no change in the production of beans in agrivoltaics. In tomatoes, about 10 or 11, and maybe a small reduction, but only a small reduction in production, but you saved half of the water, and you still did better than growing in the full sun conditions. So lots of promise, good indication of potential for this. Now I will move from showing you graphs to talk about the broader context. Beyond the science of benefits in terms of food and energy and water, agrivoltaics, we are seeing benefits because it keeps farming and agriculture in the community. And what I mean, I showed you this picture from California where the crops are no longer there. Instead, you have only renewable energy. This changes the identity of the community. Yeah, if you no longer have farming and you only have renewable energy. And Jose, you can jump in if it's not very clear. So again, there are ways to continue to have agriculture in the community with the transition to renewable energy. And this is a picture from our site in Colorado. This example, this guy, he is hace 40 años, como yo. And he inherited this farm from his grandfather. But this guy, Byron is his name, he is not a farmer. He'll tell you, I'm not a farmer. I don't know how to do farming. And so he would lend his land to someone else to grow hay for cattle. But because of the drought, he kept running out of water. And so his hay would die, or he would have too low production to make any money on his hectares of land. And after 3 years of bad production, he said, I will just put it into solar. I will just change it to renewable energy. But thankfully, we were able to talk to him and say, there's another opportunity. It's not just agriculture or energy. You could do both. And so now you can see all of the food production that happens. So the farmers have jobs. The farmers are selling the food to the community. And this place that would not have fresh food still has fresh food because of the renewable energy. And you say, well, why didn't he just plant crops instead of putting solar? Because he now has enough water because of that water savings that I was just showing you. We use less water to make the food here. The other part is income, money for the farmers. Sometimes the farmers have a very volatile market. The price you get each year changes wildly, but you can now have a more consistent additional income from having the renewable energy. And again, access to better working conditions under climate change for the people working in the shade. So in that example in Colorado, and Jose Angel and Aaron have been able to visit Tucson y Montserrat también, we're able to see what it's like to work, to do farm work in the shade of the solar. And we take the temperature. You know this from COVID, taking your temperature. Taking your temperature during the day, your skin will be about 42, 43 degrees Celsius. But in agrivoltaics, 10 to 12 degrees Celsius lower, which means you're thinking about this challenge of warmer conditions and heat waves being bad for people, the farm workers. It means a better working condition. The other thing that's very exciting about this potential collaboration is that, like these two institutes and these centers, we have undergraduate and graduate students that do work with us, but we also work with the community. And one of our agrivoltaic installations is actually at primary school, Escuela Primaria. Well, you can see for kids that are, I say, cinco años a 10 años. And they're growing the food, and they're making the observations, and they're doing science and math using the agrivoltaics data. And that is because of a connection to the University of Arizona's Community and School Garden Workshop. And in this project, we have 60 students, undergraduates, who work with us on lunes. We come to the classroom, we talk about the challenges of growing food in our area, and the rest of the week they go work with the community. So the students of the university work with the students of the community. And again, we help them do measurements. Like Monse came for 6 weeks during the summer from UNAM. We also have students who come from all over the US and do projects with us. And then we also bring the students from the community up to see our research sites when it's not at their school. And this is like the center that we were visiting, the vet center, where you bring the community to see the research and try to explain, how this is another possible way of doing this work. Maybe I'll show you one more research example. And I want to show you this example because it is a science question that came from the community. It came from a estudiante in the community. They said, if agrivoltaics changes the medio ambiente, changes the environment, does that mean you can change what crops grow in that environment and at what time of year you grow crops in this environment. ¿Entiendes? Understand? And we said, good question. And so for us, no sé cómo se dice carrot en español. Zanahoria. Okay. We would plant carrots. Typically in Tucson, you plant them in November. So right now. And this is pictures from November. You can see the irrigation spots and the students were planting carrots. But look, there are already carrots growing in November because it was much cooler. So the carrots they planted in September were alive. So by the time you get to late November and the carrots are ready or growing, they're not ready, the carrots are growing, it's time to harvest in agrivoltaics. So you started your growing season earlier because it was shadier and the ground was more wet. And so the plants thought, it's November, it's time to come up. They were tricked. And here's our teacher harvesting some carrots. Another example is Aaron was telling me here you don't always get to freezing, but sometimes you can get freezing at nighttime. In other places in Mexico, you do get freezing at nighttime. This was from just after Christmas 2 years ago, where we did have freezing conditions. And you can see in agrivoltaics, these are, again, no sé cómo se dice, sweet potatoes. Sweet potatoes grow and see some marigolds in agrivoltaics and in the control, the full sun. And these experience freezing. And so it killed those plants, but in the agrivoltaics, the freezing did not kill them. So it extends the growing season. And one last example, also because the good smiling faces of children. Here is a basil plant. This basil is only maybe half a meter tall, but you can see the basil in the agrivoltaics is just over 2 meters tall because it grew right through the winter and right through the summer. Now it becomes a perennial plant. So in the United States, we have these projects. Each one of these in the green represents places where we are doing agrivoltaics with grass, forage grass for animals. Places where you see the pumpkin is where we're doing experiments with agrivoltaics and crops. And we just received a new grant from the US Department of Agriculture to add sites in northern Arizona, where we have indigenous populations of Navajo and Hopi, como the Yaqui in Mexico, also in Illinois, and also in Texas. And we're starting to expand our research. So we are not just doing food crops, we're also looking at solar with grazing. Animals also, as you probably know, do not love extremely cold and do not love extremely hot. They like to migrate around, and in the summer, will like to be in the shade of the solar. We've seen this because we will set up cameras to watch where they go during the day, and you can watch them eat in the sun and then go hide in the shade. What does this mean for their health when you can have a more regulated temperature of these animals? And we're also starting to work internationally. We have 2 projects in East Africa. This one is in Kenya. I think this picture is also very funny because I know I'm tall like Jose Lever, but come on, I look like a giant in this picture. But this is from Kenya near Nairobi. And we also have agrivoltaics in Tanzania to the south of Kenya. At this point, also, agrivoltaics project is in the Arava in southern Israel. And so we're really building this solution. And I think in the United States and probably in Mexico, the public is ready for a solution. All of the students have been going to school hearing about climate change. Yeah, you've been going to school hearing about how our food system is not sustainable, how we need more renewable energy. And every time we talk about this topic, we see it in the news again and again. But what we're saying is there's an opportunity to do something different. We're pushing this edge of a new way of thinking about food and energy production. And our students are being a part of that new wave at the University of Arizona. And we want the students here to be a part of that new wave of how do we think about a model for new ways of doing farming in a warming world? So part of that, working together for a solution is, and don't worry, I'm almost done, is to develop a common set of ways of measuring agrivoltaics across space and across time. And think if we're trying to create an international collaboration, we have the deserts of the Sonoran Desert of Tucson. We have the extreme desert of Israel. We have the tropical areas of Kenya. We need an area in the tropics that goes through seasonal wet and dry cycles. We need high elevation sites to build, to fill all the pieces of the puzzle of how well does this work across the globe. And we also need to do better jobs of talking, kind of like this signing that happened today. Bring together our understanding from agriculture, and we need to add a picture of a vaca and a sheep. I already forgot the Spanish word, sorry. And goats. We need to learn about what are the challenges for agriculture. At the same time, we're hearing about the challenges from renewable energy, so that together we design a system that can be optimal for both based on what the community is asking for. And again, as we've been talking about, we need to calculate the costs and the benefits that come from this system, not only in terms of food production, the dollars you get, but also about keeping agriculture in the community so that there are still jobs in these rural places, so that we can start to learn about the indigenous ways of surviving in these lands and apply them to this new system. The cost, not only the dollars you saved in terms of water, but the fact that you could continue to produce food in this place because you now have shade from renewable energy. And we can start to think about all of the different benefits that come with these kinds of agrivoltaic systems. And that's what it takes all together, different disciplines, to really assess the potential for agrivoltaics across the globe. So in the beginning, I showed you this graph where we were talking about energy and food production and water savings, but it's so much more. It's also thinking about a future that gives us more energy resilience, especially in terms of the climate change and mitigating climate change at the same time. And from the food system, it's also mitigating, not just creating food, but mitigating the changing climate's pressure on our food system so there's more resilience. We can continue to produce. And food access. If we start to have remote rural areas get rid of agriculture and only have renewable energy, you start to lose access to fresh foods. And again, saving water is going to help create more climate resilience. In some place, there's a conflict for your land. Do you want to use the energy for power, or do you want to use the energy for food? I want to use both. And I hope that together we can find new ways to create a more sustainable future. So we hope that Mexico will be a partner. This is what happens when you let a boy from Texas on a tractor. I also have a big hat like I saw at the center this morning. We are working towards creating this international school of agrivoltaics, an international way of learning about food, energy, pressures, and possibilities. And we want to find partners across the Americas. And with the collaborations that have been started with the help of Jose Lever, we hope that we can work together. And I want to show you that it's not just me. There is an entire team, a diverse team of people, diverse not only in our races, but in where we come from. So Diana is from Kenya and came to work with us so we can learn about on the ground practices in Kenya before we try to take solutions to Kenya. Caleb, his parents are from Mexico and his grandparents are Yaqui. So again, he wants to take solutions back to his way of doing. Mariah here was a food science major, like food science, like food chemistry. But this was important because we needed to know, does agrivoltaics change the flavor? Does agrivoltaics change the nutritional quality? So again, we have to recruit from different disciplines to create the team that can look at this more holistically. Okay, yes. Well, regarding flavor, especially for the chef in the room and anyone who loves to eat. So Mariah did her master's project and she just completed it. And so I showed you, and Monse, you helped with this also? Yes, okay, good. So even your local Mexican expert on agrivoltaics has been a part of this study. So we took crops, basil, tomato, potato, squash, and chiltepín, and frijoles rojo. And we gave the people at the university an opportunity to do a taste test, but a blind taste test. They had a sample chopped in a little bowl, and on the bowl it had a number. And only Monse and Mariah knew where it came from. And so each person was given a sample, 2 samples, and they said, which one they prefer, or if they can tell no difference. And across basil, tomato, potato, squash, chiltepín, no one could tell a difference. With red beans, they could tell a difference in the texture, but they didn't have a preference. They could just tell the difference. Another question we had then was, if you could tell a difference, if you had a preference, if you knew that it came from the setting of agrivoltaics instead of the regular setting, would you pay less because maybe you're nervous about this weird system? Would you pay the same because whatever? Or would you pay more because it's part of a sustainable solution? And 60% said they would pay more. 40% said they would pay the same. No one said they would pay less. And so there's a real opportunity here to think about not only ways of keeping agriculture, but even accelerating acceptance of crops because of this growing in this agrivoltaic setting. So again, what will happen with the food crops here in Mexico? Necesito un estudiante to do this work, yeah? Okay. So that's for me, that's everything, and I will wait for your questions.
Comentar que además de los que estamos aquí reunidos en el auditorio, en redes tenemos 214 personas también siguiendo la plática. Entonces empezaremos por preguntas. Si alguien tiene alguna pregunta, Francisco Galindo, la puedes hacer en inglés y después la traducimos, o hazla en los 2 idiomas, por favor.
Well, thank you very much. Thank you. My question goes in regards to the graph you showed of the ecosystem services.
Espérame tantito, Pancho. Te van a dar el micrófono, si no la gente de redes no va a escuchar nada.
Hola. Okay. ¿En inglés entonces?
Sí, y después en español, por favor.
Yes, I want to repeat it because no one, well, there's people connected. So, first of all, congratulations for your talk. My question goes in regards to ecosystem services not being provided in different areas. I presume that biodiversity could be a very interesting service to measure. Have you been able to measure sort of biodiversity of insects, for example, or in relation to organic matter in the soil? Because I presumably have better quality soil, or other types of biodiversity in relation to birds or mammals. Sí, mi pregunta iba en el sentido de los servicios ambientales que se pueden proveer a través de esta tecnología, que además de lo que han medido en función de gases, si han tenido oportunidad de medir biodiversidad dirigida a insectos o a la calidad del suelo o a biodiversidad de aves o de mamíferos.
Yes, thank you for the question. Yeah, and for those of you who are not familiar with this idea, we talk about ecosystem services as all of the things we receive from our ecosystems. It's very human-centric idea, but we're also considering everything that benefits to the broader natural ecosystem too. It is kind of like the graph that is on here. In this kind of ecosystem, you get energy production, you get that transpirational cooling, you get carbon sequestration, you get forage for biomass. It's a way of accounting for everything we get. And an additional thing we should account for is the biodiversity, not only the biodiversity in the vegetation below the solar panels, but in the biodiversity that they attract in terms of insects and birds. All of our projects have been on the crop side of the system, but we just signed an agreement to do a project with a new solar installation. It's north of Tucson, and we will restore habitat. So I think I showed an earlier graph. It's just solar panels with dirt, very low biodiversity, the opposite of biodiversity. And so we are bringing back natural biodiversity of the vegetation to attract biodiversity of insects and birds. Other places around the United States are studying insects and birds by walking through with nets to get a sense of what insects are there, and to use cameras that take pictures when there's motion to capture images of the birds that are there. But this is not our research yet. It's also not my specialty, and so I would welcome a collaboration for this.
You mentioned something about pollinators generating bees.
Yes. Okay, so also Jose asked me to mention projects about the inclusion of bees. So bees are very important pollinators. And so part of what we are doing is intentionally bringing plants that will attract natural pollinators of bees. Bees do an enormous ecosystem service for us. Because you're in the vet school, I'm not sure if you know fresa? How many times do you think a bee has to visit the flower of a fresa to get a strawberry, a fresa? Uno? Cero? 15. For a blueberry, 20. So you really need to attract pollinators, especially if we're bringing renewable energy to agricultural zones like the center. Even if you have renewable energy, you can still support the neighboring agriculture by supporting the biodiversity and the bees that do that pollination. Thank you.
Otra pregunta. Ahí hay. Y después ahí hay otra pregunta.
La hago en español, Doc, y si me hace favor de traducirla. Muy interesante su plática, muchísimas gracias. Mi pregunta va en el sentido si han considerado llevar a la par de este interesante proyecto programas educativos, en el sentido de que la gente tenga un uso racional también de los alimentos, porque de nada nos sirve producir alimentos si el consumidor final lo desperdicia. No hay mucho desperdicio de alimento. Entonces, no sé si han considerado hacer programas educativos. Y además también en el sentido de si dentro de su programa de investigación, ¿cómo piensan transferir este tipo de tecnología a la población normal para que puedan adoptar esta tecnología?
Primero en inglés, entonces. Okay, good, thank you. It's much better that way for you too. Yes, so I think, as I understood, the first question is, do we also measure the biomass, the production? No?
Education programs.
Oh, the education programs, yes. Okay, so yes, in multiple ways. I showed some pictures of the students working at a primary school, and that is just one school. And so we wrote a proposal to the National Science Foundation in the United States so that we could bring the education to other schools that don't have solar. And so what we did is we made a small agrovoltaics. I call it agrovoltaiquito. Okay, a little crate like the micro parcels we will use, but with, instead of solar way up high, with solar just over the micro parcels. And this way, the students could still see the impact of the shade of the solar. And we also had to think about ways of showing the students what is renewable energy. Because if it's just a solar panel sitting there, it doesn't do anything. And so we connected it to a pump for water to show under good conditions, and then we would shade it and you'd see the pump lower. We would have it connected to the pump connected to the solar that's over the ground versus over the agrivoltaics, and agrivoltaics is doing better. So you could see the how high it was pumping the water. You could see the difference. I think this is another great collaboration between the University of Arizona and UNAM and the center, because you also welcome people to come see the work that's happening.
You also mentioned the workshop.
Mhm. Okay.
Un momento. Pero tu pregunta, Gina, también fue educación hacia los consumidores, ¿verdad? Mhm. And education to the consumers of food,
Okay.
not to waste it.
Okay. Yes, and so then the other part you're asking, I think, about how to utilize this food, because, well, in a lot of our examples, we have the young students growing the food, so they feel ownership of the food. This means that more often they are likely to try different foods. And so part of our program, we've created something we call the Food Literacy Laboratory. Literacy being, your understanding of something. And so in the lab, we will bring the food that we grew, show them how to cook it, show them knife skills, how to blend the food, how to create a recipe. And then we give them food in a bag to take to their house. Now the estudiante is the maestro for the family to show how the food is being used.
And the other part of the question is the transfer of the technology.
Okay. And for the última question about the transfer of the technology, this is where we're at a gap. We do not have a good system for transferring the technology. This is part of why we're trying to make more collaborations with specialists in renewable energy, so that we can calculate the cost, because you have to, in some cases, raise the solar panels higher. So that means a cost. And how do you relate those extra costs with the benefits of having food access and food production? This is where the technology is. Small businesses are starting to be created in Mexico and Germany and France and the US to try to bring this approach to people. There's lots of people doing renewable energy the regular way, but only a few people doing it this new way. It's an opportunity.
Rafa. Y después el doctor.
Buenas tardes, gracias por la interesante conferencia. Dos dudas, una es un poquito técnica, es saber si se ha hecho algún tipo de estudio de la afectación del campo electromagnético producido por la conducción de la energía producida hacia las plantas, y saber qué tipo de estudio se ha hecho, si es que se ha hecho o si es que se ha considerado. Y la segunda es un tanto dirigida a la legislación. ¿En México han tenido algún tipo de problema con la legislación actual para la producción de energía eléctrica por celda fotovoltaica, o si se vislumbra algún tipo de problema posterior por los nuevos cambios que se quieren hacer justamente a las leyes de producción energética?
About agrivoltaics or
No, energy production.
okay. All right.
Yeah. Okay. Sí.
Oh, gracias for the pregunta. For the first part, the electromagnetism impacts on the plants, we've not measured this. This is not the field of science I do, but thankfully, Raul Sanchez does study such things in terms of electromagnetism. I'm not really sure how we will study that in terms of the plant's function, but it's a question to consider. But no sé.
Y el doctor Aarón va a hacer un comentario. Si le damos el micrófono, por favor.
Gracias. Con respecto a tu pregunta de los efectos de la radiación electromagnética, pues vivimos en un mundo en donde tenemos radiación electromagnética, nosotros como humanos, ¿no? Y no se ha detectado cambios significativos o efectos significativos en las plantas, ¿no? Entonces no hay, podemos garantizar que no hay efectos ni acumulativos que vayan a ocasionar daños en las plantas, en el caso del uso de la tecnología fotovoltaica en aplicaciones agrovoltaicas, ¿no? Con respecto a la parte de la legislación, todavía está permitido instalar hasta 500 kilowatts de potencia fotovoltaica, media hectárea, para que tengas una idea de tecnología fotovoltaica, sin ningún problema con respecto a la legislación.
Sí, sí, tenemos varias preguntas aquí. Hay una pregunta vía Zoom en donde están preguntando cuánto cuesta por hectárea este tipo de tecnología. How much does it cost for to set up this system? Do you have an idea?
Okay. I can speak to the additional cost of renewable energy plus X to do agrivoltaics. It seems like it's about 10% additional cost to go from regular renewable energy to do agrivoltaics because of the extra steel, extra metal to elevate the panels because you need to get them higher for the crops. This also means they are more exposed to wind, and so you have to have more steel below the ground for stabilization. If you go only to 2 meters, it's not very much more expensive. If you go above 2 meters, the cost increase even more because it's more difficult for the people to do the work of the solar panels on top.
El doctor Juan Garza, después la doctora Marina. Y había alguien más que levantó la mano, la compañera.
Sorry, I came late, but my question is this. Arizona does not have coast. It's not surrounded by sea. However, Mexico has more than 12,000 kilometers of coasts. And we are now thinking in a new energy, which is already working in some countries, in some areas. Solar energy is only in daytime. Wind energy is only certain times and quite often is in certain times of the year. However, the waves in the oceans work 365 days, 24 hours. How would you compare the production of energy, clean energy, in these three cases and the agricultural side? Thank you.
Yeah. Oh, that's a good question. Here's my area of expertise, and here's your question. But I can say, yeah, you're absolutely right. There is more time that you have wave production, but I don't know, I have no idea about the efficiency in terms of the production of renewable energy from the waves. I would have to defer to someone else about the renewable energy. You're absolutely right that wind and photovoltaics means you have to utilize land space, and so there definitely are trade-offs between the two. This idea does not mean that it's perfect for everywhere. That's for sure. It's more about one way to consider not giving up land for renewable energy without thinking about how to maintain land for food production. But it's a valid point to think about multiple ways of using renewable energy. Not saying this is better than that. It's an alternative for on the landscape, on the terrestrial biosphere.
Ya se me olvidó lo que te iba a preguntar. La verdad. Ok. No, wow, ¿por qué se me olvidó lo que te iba a preguntar? Es que me quedé pensando en la pregunta del colega. Sí, ciertamente deberíamos de ver qué onda con eso en el instituto, ¿no? Pero básicamente, ya recuerdo. Básicamente, en México hay una manera de hacer agricultura que es la que la madre naturaleza ha dado, que es la milpa. Es una manera de hacer la agricultura en donde se crean los propios ecosistemas y son milpas que no son iguales. En un ambiente semiárido o árido, lo que cultivan son plantas diferentes. Entonces son una selección de plantas que tienen propósitos muy claros. Uno de ellos es minimizar todo lo que es un agente invasor, un bicho, algo, de alguna manera, ¿no? Sin utilizar los agroquímicos. Entonces, ¿cómo verías tú en el ambiente de la milpa, que es lo que utiliza el agricultor en México, y los agrovoltaicos? ¿Cómo harías tú, cómo le venderías la idea de un agrovoltaico a una comunidad que está muy enamorada de su milpa? Y eso tiene que ver con otra pregunta que ya te la hicieron, ¿no? Yo tengo mucha curiosidad de ver cómo ese microambiente de bichos cambia cuando tienes el sol directo o lo tienes bajo sombra. Ajá. Porque tuvimos un problema en México que nos cayó un ácaro en las palmeras, dejó sin palmeras toda la costa veracruzana. No hubo manera de controlar el ácaro y a lo que le apostaban es a que otro bicho se lo comiera. Entonces, cuando tú cambias temperaturas, cuando tú cambias un montón de cosas en ese ambiente del sombreado, ¿cómo se protege eso? O sea, yo tengo mucha curiosidad de quién está haciendo ese estudio en el caso de los agrovoltaicos, los microsistemas de bichos.
Okay, that was a question and a good lesson. So thank you. The part of your question about which species do we use and how do we select, is in every case is driven by the community where we are doing the work. And so we picked crops for our agrivoltaics project in Tucson that were food crops people are already growing. When we went to the project in Colorado, again, we waited and saw what crops do they grow there. I'm really glad that you mentioned native crops because they represent a genetic resource that we have really forgotten about in a lot of cases when we think about larger scale production. What I mean by that is sometimes you can buy a little pack of seeds from the store, but they're not from your region and they may not be suitable for your region. They may not do their best production from your region. But if you can find some of the native crops, that's what we were trying to do with some of our projects. So instead of just going the, I don't want to say green bean, frijole verde, or a French bean, I don't know. We will grow tertiary beans that are from our region because these are plants that have also survived through lots of droughts and hot temperatures, and to survive in our climate you have to be resilient, and so it's another good resource. The other plant that we've been seeing do very well is the chiltepine. So the natural history of the chiltepine is to grow in the shade. It grows in the shade of the prosopis because you have to survive through drought and high temperature. It's not a cactus, so how did it survive? It survived by living in the shade of something else. And so agrivoltaics is replicating its natural system to grow, and that's why it's doing very well. So we're trying to take lessons from nature, observe their natural growing conditions, and see how well they can work here. But we're very intentional not to bring in invasive species. So when we talk about the project at the center, we would want to study local lettuces, not bring a lechuga from Texas and try to study it here. We would not want to bring in invasive species.
And the soil diversity or the studies that we're going to be doing in soil in and out.
Okay. And with respect to the soil also, we're also very intentional about this project being organic, or at least, I forget the word that you use, not organic, but agricultural. Agrovoltaicos, más o menos. By using lots of the waste from the cows and the chickens and the sheep to create a nutrient-rich microbiome for the plants, but the microbiome comes from the animals in that region. Just like at the center, you take the waste from the sheep and bring it to the community. We also want to use the local, so we're not reintroducing pathogens from outside the community into this agricultural system. I'm not sure if this is the right question you're asking, but we will also be studying the nutrients in the soil, the carbon buildup in the soil, so you can think about the carbon sequestration and the storage, the microbiome that's being created. Because we know from our whole One Health that a good soil microbiome creates a good vegetative microbiome, and what we eat is good for the animal microbiome. Yeah.
Gracias. So you mentioned that farmers had an increase on their incomes, and I wanted to know what was this main source, because I understand that you have more harvest, but as well, I would assume that it was because they're selling energy, right? And because for what I get, this proposal is to produce more energy than the one that I'm just consuming myself in my farm. So if I wanted to know if that was like the main source of income, because here, as they mentioned, like Mexican legislation is very different, and that might be an issue if that were like the incentive.
So there are multiple, the question was about the ways that you see income or even more income. In terms of the farming, we saw more income because of greater production. And in some places we saw more income because you were spending less for the water. And in Arizona, water is not very expensive. It's actually the problem. Water is very cheap, so everyone uses lots of water. In Colorado, a different state, the legislation is that it's more expensive for the water. So their water bill, the amount going out was cut in half, but they were still selling the same amount or even more crops. And so that's where there is a balance in terms of the economics. But you're absolutely right that the biggest increase for the farmer in terms of income was from the renewable energy. The guy Byron I showed a picture of on the tractor, his mom did not want it to be renewable energy. His mom, her dad was the original farmer for the land, and she did not want it to go away from farming. And Byron said, look, we were losing money every year. And the final year, they planted nothing, and there was dust. They made dust for everybody. So then the other neighbors were mad. And she said, okay, fine, we'll do agrivoltaics. At least it's keeping agriculture and adding solar. But now they get a monthly check for the energy. It's 10 times what they would get for the food. So now she's happy.
You're not necessarily selling the energy, but you're using it to cool, to store your product, or perhaps dehydrate, and that's another way of getting.
Thank you, hermano, for the prompt, the reminder. So another opportunity is that example from Colorado is when they're connected to the electrical grid. So there's expenses that come with connecting your solar to the power lines that take it to Denver or wherever. But in these smaller situations, and sometimes where you are not connected to the grid, we say off grid, the benefits to the farmers are one, like at the center, where if you can produce 60% of the energy to run the center, now it's coming from that. That is income that can be used for something else. For our project in Kenya, all of a sudden, more than 60% of their energy costs, because they're like the center, they're also an educational place. So power for the lights during the school, power to keep the lights on after the sun goes down, power for the pumping, all of this power was now offset by that renewable energy. It meant they had resources to put towards something else. And what they chose to do was build a greenhouse for growing tomatoes. So they used their savings to buy something that had a lot more value. That's one example. Another example is how they're using the energy to create cold storage. The distance between the farm to the market was so far that sometimes the food would go to waste before it got to the market. And so now they had cooling on site because of the renewable energy. Aaron Sanchez as a group has been looking at dehydration, desiccation, dehydration of the crops as another way to extend the time to the market or extend the type of market. And so this is another mechanism to utilize the renewable energy for your farm to better your income because you have less loss and also a new type of market. And the last example is in Kenya, we asked them what they wanted to grow. Back to your question, they wanted to grow spinach because they have the staple crop. The staple food always has spinach in it. They wanted to grow French beans because they knew that's what they call green beans because it's good export. The last one is fresas. Fresa. You don't grow fresas in Kenya. And they said, yeah, but maybe now. And so a new opportunity for a new crop.
Sí, yo con base en esta pregunta que hizo nuestra compañera, quisiera platicarles una experiencia. Es un rancho de 100 hectáreas en el estado de Tlaxcala, en donde ellos colocaron 150 metros cuadrados de paneles solares, no de tipo agrovoltaico, pero para producir energía. Ellos pagaban 13,000 pesos a la CFE cada que llegaba el recibo. Cuando pusieron los paneles solares, ellos ya solamente pagaban 300 pesos. Entonces, no venden la energía, pero se ahorran tal vez en el consumo de energía que están teniendo en la instalación.
I'll just end by saying there's the website. From there you can find our contact information and I welcome more questions online.
Hay otra pregunta. There is another question.
Thank you very much for your talk. Very, very interesting. Have you worked with alfalfa? I asked the question because alfalfa is very water demanding. So it would be an interesting plant to look at with your research.
Yes, alfalfa is a great crop to consider because it's also widely grown in Arizona. I should say it used to be widely grown in Arizona. Because the water levels of our aquifers are dropping, farmers are now getting limits on how much water they get. Already 25%. Next year in January, 50%. So imagine you have 100 hectare farm for alfalfa, but suddenly you get half the water. I'm not sure that they will continue to be able to grow alfalfa. The other challenge with alfalfa is that very large machines. And so to do this work, you would have to space the solar farther apart. So it is something we're considering. The challenge is, do we create an experiment to study a crop that may be going away? It's a challenge.
Ernesto.
And what about grazing? Having animals grazing the plants? You cannot have sheep, goats, or cows grazing alfalfa, the whole thing alfalfa. You need grass.
Yes.
Could you do that? Could you have animals grazing under the panels?
Absolutely. Definitely. In one project, we're actually actively creating a database of native grasses, again, so we don't create the wrong kind of community, bring in the wrong predators, but it is specifically so that the land can be managed for grazing. And in terms of a vet school, the context is yes, because then you have good forage, good water use efficiency, shade for the animals that improves health. From the renewable energy perspective, it's actually less expensive to maintain your ground cover by grazing than it is with mowing. The other part of with mowing, you leave dead grass, and in dryland environments, you could have fire. But in the grazing, the grass is literally gone, right? What's left behind is nutrition for next year's grass. So, absolutely.
Sí. Okay. ¿Existe alguna otra pregunta? No. Si no, pues sí, doctor Suárez.
Yo quería, o quiero, sí, agradecer a nombre de la Facultad de Medicina Veterinaria y Zootecnia a la directora Marina Rincón. Muchísimas gracias por estar con nosotros. Sí, creo que también agradecer en forma muy atenta a Aarón Sánchez. Muchísimas gracias por tomar en cuenta, en ponernos y incluirnos en cierta parte de tu experimento aquí en CEPIPSA. Y a Greg, muchísimas gracias también por tu participación el día de hoy. Creo que abre una muy buena área de diálogo y posible cooperación con Arizona. ¿Sí? Como todos ustedes saben, la UNAM tiene un centro en Arizona y creemos que esto puede ser muy efectivo. Ya lo habíamos platicado muy bien con Pepe. Muchísimas gracias por todo tu apoyo. ¿Sí? Y antes de despedir la conferencia, pues quisiéramos, está en español, pero de todos modos ya veo que sí le entiendes, ¿sí? Y es la historia del caballo durante la Revolución Mexicana.
Gracias.
Un poquito pesado para llevarlo de regreso, pero vale la pena. Muchísimas gracias. Ahora sí dejo que despida la conferencia.
Sí. Pues muchas gracias. La verdad es que creo que las preguntas también enriquecieron mucho. Es una gran oportunidad para nosotros y es hacia donde la Facultad de Medicina Veterinaria y Zootecnia está enfilando sus baterías. Afortunadamente tenemos muy buenos colaboradores y creo que estaremos visitando mañana en Tequisquiapan, otro de los centros, para ver las oportunidades que ahí también podemos tener. Gracias a todos y que tengan buena tarde.